Welcome to Study Loop.
This is the answer to Chapter 21, problem number 69 from the Smith Organic Chemistry textbook. This problem talks about tert-butyldimethylsilyl ethers as protecting groups and introduces a different protecting group, the methoxymethyl ether or MOM protecting group. And so we're asked several questions about that. So the first one is write a stepwise mechanism for the formation of a MOM ether from cyclohexanol. And so this is a pretty straightforward mechanism. So we have sodium hydride as a base, and it's just going to deprotonate the alcohol. So the hydride will grab that hydrogen. The electrons from the bond will revert to the oxygen. And so we get the deprotonated oxygen here. Okay. And now that deprotonated oxygen is going to act as a nucleophile. So we have the MOM chloride. Which looks like this. And so the oxygen is going to attack this carbon. The chloride is a good leaving group. So the chlorine will take those electrons and go. And that gets us to the protected alcohol. So at this point, we've installed the methoxymethyl ether protecting group, or the MOM ether. Okay, and so the next question is, what functional group comprises a MOM ether? And so looking at this, what we see is one carbon that has bonds to two different oxygens. And so from this chapter, we know that that is an acetal. So the answer to part B is going to be acetal. Okay. So that's part B. And then let's see. Part C is, besides cyclohexanol, what other products are formed by aqueous hydrolysis of the MOM ether? Draw a stepwise mechanism that accounts for the formation of each product. Okay. So part A was putting the ether on. Part B here is going to be hydrolyzing the ether off, or deprotecting the alcohol. Okay, and so we will start from here. Okay, so we have our protected alcohol. It's going to be hydrolyzed off by aqueous acid. So we can draw aqueous acid like this with a positive charge on the oxygen. We'll put our lone pairs on these oxygens. Okay, and so one of these lone pairs will grab a proton, become protonated. And then, of course, the next step will be that oxygen leaving as methanol. So once it's protonated, it's a good leaving group. Or, sorry, not methanol. Oh, yeah, it's methanol. Okay. So the problem specifically asks us what other organic products are made. And so methanol here is going to be one of the other organic products that is made. So now we are at this point where we have a carbocation on this methyl group. And so what can happen here is that water can come and attack that carbocation. And so that is what will happen. Okay. And another water can come and deprotonate that water that just added. All right. Oh, did I drop a carbon? I did. Okay. Okay, sorry, give me 1 second. I need to fix this. I dropped a carbon. Apologize for that. At least I caught it now before I finished the entire rest of the mechanism. Okay, so this is an oxygen, and then there's a carbon here, and then the other oxygen. Okay, so I just dropped a carbon in that one structure. But yeah, at least I caught it then, right? Okay, so after that oxygen's deprotonated, we're here. And then basically what can happen next is protonation of the oxygen that's closer to the ring. So another molecule of acid can be called upon to do that. So this oxygen can get protonated like this. And then once it's protonated, this bond can break and the electrons can revert to the oxygen there. And so that is going to give us our cyclohexanol back. So here's our cyclohexanol. So that's obviously going to be another organic product of this hydrolysis. And then there is going to be one more product. So we'll also get this, so CH2OH. So with a carbocation here. Okay, and we can draw a resonance structure for that molecule that looks like this. And actually, let me move it over a little bit. So CH2OH. So now the positive charge is seated on the oxygen. Okay, and that oxygen can be deprotonated by an equivalent of water. And so that is going to give us our last organic product here, which is going to be formaldehyde. So we'll get methanol, formaldehyde, and our cyclohexanol. Okay, and so those are the three organic products that this reaction produces. It's a stepwise mechanism that accounts for all three of them. We also answered part B. This is an acetal protecting group, and the mechanism of the protection is drawn out in part A. And that's the answer to chapter 21, problem number 69.